Alright, so I want to talk about quantum tunneling. A lot of people have been asking, could you use quantum tunneling to, teleport? And this is kind of a fundamental misunderstanding of how it works. Let me explain. You may have heard in pop science that quantum tunneling is what happens when a particle moves toward a surface and its waveform extends behind the other side of that surface, and then you take a quantum reading and suddenly it's on the other side of that surface. And that sure does sound like teleporting. But really all this is someone talking about an object in two different ways, once as a wave and once as a particle. All particles are fluctuations in quantum fields. They're all waves. The entire wave is that particle all the time. That's where the particle is. Now, what that wave is mapping out is the probability of interaction with some other wave. When an interaction occurs, we like to point at the spot where it did and say, that's where the particle is, but that's kind of wrong. The particle is everywhere the wave is. So if a particular wave function overlaps a surface such that some of it is on one side of a surface and some of it is on another side of a surface, if we take a reading of that wave, and at one point we see an interaction on one side of the surface, and that wave doesn't move, and then we take another reading, and we see it on the other side of the surface, that isn't an object teleporting. The wave hasn't moved. We have just seen it interact in two different spots along its wave function. So quantum tunneling isn't really teleporting. The wave function, the thing that is the particle, hasn't really moved anywhere. In fact, it hasn't really changed at all. Usually when something moves, we could at least describe it as a wave function change. Like the wave function says, I'm here, and now I'm here. But that's not really what is happening with quantum tunneling. So, no, it's not really teleportation. And for everyone out there that says we could use it to move faster than light, no, we can't. So yeah, remember, when we're talking about particles, they are waves all the time. And when you see an interaction on two sides of a surface, really you're just talking about the same particle, but you're talking about it in two different waves. You're talking about it once as an interaction, once as a wave, and again as an interaction. It's kind of like saying, I teleported because I am here, and now I am here, when really they're just both sides of my head. I was in both places at once. I didn't move. Similarly, the waveform was in both places at once. It didn't move. And that's what quantum tunneling is. It's cool, but it's not teleportation.